Welcome to Professional Perspectives with the Michigan Green Chemistry Clearinghouse and Dr. Clinton Boyd.
So my name is Clinton Boyd. I work for Steelcase, which is a global manufacturer of office furniture. I work out of our global business center in Grand Rapids, but we have manufacturing facilities throughout the world. We are one of the largest office furniture manufacturers. My title there is Principal Scientist of Green Chemistry and Sustainability. So pretty much my day-to-day is working on chemical issues for Steelcase, which covers the full spectrum from regulatory issues to sustainability issues to innovation. So green chemistry, so on a day-to-day basis I work on green chemistry, but through all three perspectives, from a regulatory perspective, a sustainability perspective, and how we innovate new materials for our products.
What first piqued your interest in green chemistry?
So for me, green chemistry came at the right time in my life. It was like a juxtaposition of both professional and personal interests. On a professional level, I had been working, I'm trained and worked as a research biochemist. So I spent most of my first part of my career working in university settings as a research biochemist. And I focused on how chemicals in our environments contribute to neurodegenerative diseases and cancer. And on a personal level, I've always been very interested in the environment and kind of the natural world. And right about the time when I was changing careers and looking for new opportunities, I joined a consulting company, a small local company, on sustainability, and I was very intrigued to start working there. And as I was looking how to kind of balance this new career path with my past, green chemistry became this perfect kind of solution, because it was very apparent to me, at least, that the chemical dimension of sustainability is kind of an undertow in everything about sustainability, but it's not really brought to the forefront. So given my experience with chemistry, and specifically how chemicals impact the environment and our health, green chemistry was a definite, it's a perfect timing and a great framework for me to start structuring my thinking and the consulting services that this company provided around sustainability.
What is one design challenge that you've had to overcome using green chemistry?
So I think this question also helps your first question, was what are the big trends or what are the big opportunities out there for green chemistry? Because that is the heart. What you said, what's the design challenge? And I think that's what we have to appreciate, is the new thing that green chemistry brings to the field of sustainability. We speak about how it's been well recognized for a long time, this concept of design for environment is kind of the central underpinning of sustainability. It's recognition that most of the environmental impact a product is ever going to have over its whole life cycle, not just its manufacturing or its use or its disposal, but its whole life cycle, is actually locked in during the design phase by the materials you choose, the chemicals you choose to make that product. So you'll hear green chemistry referred to basically as, one way to think about it is design for environment at the molecular level, recognizing that if something is going to have an environmental impact, that's a design flaw. And most environmental impacts, if you think about it, ultimately come down to ways in which chemicals interact with our environment. There are chemicals that come from our products or how we manufacture the products. So when we talk about climate change, it's caused by greenhouse gases, which is a chemical. Air pollution, or what's polluting the air, it's the chemicals. Water pollution, so it's actually chemicals. So most health and environmental impacts that you can think of are due to chemical releases, either from the product during its use phase and disposal phase, or during the manufacture of that product. So what green chemistry tries to do is to try to recognize that we're going to keep having these problems if we keep going back to the same toolbox, to make our materials, right? To achieve the quality of life that we want. We want these products, we want these materials, but we keep making them the same way. So green chemistry is not a new chemistry. Chemistry is chemistry. But it's figuring out, is there a different way to make materials to provide the performances that we want, but without doing it the same old way. So that's why it is a design challenge. So some of my favorite ones that I've seen out there are, there's some amazing things going on with adhesives, because typically when we think about adhesives, you they cause a lot of problems for industry, including our own, in terms of some of the chemicals that are in there, the nicest chemicals that we'd like to have in adhesives. But there's some things that we always take as a given for adhesives. Adhesives don't work well in water, right? But one of the greatest green chemistry inventions that I could think of was someone looking at mussels we eat on the seashore, saying, well, these grow and they somehow stick to the rock. So how are they doing that? And actually figuring out there is a way to make adhesive, work in water. So that was a design change. A lot of our best adhesives, when you think about it, you don't want adhesives to come loose, right, in your product, but while you're using the product. But when you're finished with the product, one of the biggest hurdles to recycling, which is essential to sustainability, is the fact that we use mixed materials, and then you've glued them together so well that you can't get them apart. So what happens if there was a way, we use epoxy resins to do that. They're very good at holding things together, but they don't want to let go. So, is there a way to design a resin like that does what you want to the use phase, but then you can reverse it? And there's a company right now that's figured out how to do that. So they've effectively made a resin that acts as an epoxy, and when you're ready, you condition it with this little treatment, and it converts the thermoset resin into a thermoplastic resin, which in technical terms now allows it to be recyclable.
What opportunities do you think Design for Environment presents for manufacturers looking to make a sustainable transition?
Perspective of when we talk about manufacturers, there are obviously chemical manufacturers who kind of make bonds, and then there are what we call fabricators, right? So companies like Steelcase, where we actually take materials that are already in the market and we make value-added products like seating products, and tables, and case goods. So design for environment definitely, is both an opportunity, but it's also a challenge, because typically our business models rely on easily stable bulk materials, economy of scale. So you kind of, you have to use what's available, and there's a price point for that. There's a stable supply chain for that. So, but as long as we keep using the same materials, we're going to keep facing the same sustainability challenges that we've had. So if we want to overcome those challenges, design for the environment is where we have to go. So we either have to figure out ways to redesign our products so that we don't have to use those kind of materials. So an example would be, there's been a lot of concern about flame retardants, but flame retardants are required because of regulations, and when you use certain types of materials, like a cushion, that kind of material can be very flammable, so you may need to use flame retardants to meet the necessary regulations. But design for environment could say you could keep finding a solution to that flame retardant challenge, or you could say, is there a way to choose to provide comfort? Because what does the customer want? They want the comfort. They don't necessarily want a cushion. So design for environment is a way to think differently and say, how do we provide the service or the expectation, the need of the customer, but potentially in a different way? And it's not always a material solution, completely redesign.
Thank you for watching. Please visit migreenchemistry.org for more content and information from the Michigan Green Chemistry Clearinghouse.